Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 14, Association Between Categorical Variables. So example 1 here says, suppose a random group of people are surveyed. Okay, so random group about the use of their smartphones. The results of the survey are summarized in tables below. So we just want to take a look at these. There's nothing to do here except discuss what's going on here. So there's smartphone use and gender, smartphone use and age. So what they're trying to decide in this survey is, do you use a smartphone or do you not? And are you a male or are you a female? So they wanted to determine if smartphones were popular among males, females, and that kind of thing. So what we are going to discuss is what's being recorded. Well, it's the smartphone use and gender. Okay, so if 30 people, 30 males used a smartphone, 10 males did not. There were a total of 40 males. 45 females used a smartphone, 15 did not, for a total of 60 females. And notice the columns always add up. 30 plus 10 is 40. 45 plus 15 is 60. Those are the rows adding up. 75 plus 25 is 100. Columns also line up and add up. 30 plus 45 is 75. 10 plus 15 is 25. And 40 plus 60 is 100. The total here means total males and females combined. This total here means all the females. This means all the males. This total here means male and females who do not use smartphones. And this total here means males and females who do use a smartphone. And the same goes with over here. But this difference is under age 40, 40 years and older. Use and don't use. So 45 out of 50 people under the age of 40 use smartphones, but only 5 out of 50 under the age of 40 do not. Once you hit the age of 40 and you're being interviewed, if you were over 40, 30 said they use a smartphone, 20 said they did not. So it appears that younger people tend to use smartphones more so than older people. Okay, and you can always use percentages to determine that. This is 75 out of 100. So 75% of the population use smartphones because it's 75 out of 100. But 45 out of 75 were under 40 who use a smartphone. And these are different variables, or not variables, but different values that we can get. Okay, so if I take 45 out of 75, and I want to know the percentage, and I'd put 45 over 75, and that would be 9 times 5 is 45. So that'd be 45 over 75. And 5 will go into 45 9 times. And 5 will go into 75 15 times. And 3 will go into 9 3 times, 3/5. So it's 3/5 or 60%. So 45 out of 75 is 60%. And that is the relative frequency. Okay, so those are all the different things we can get from these two-way tables. Okay, so let's move on. And example 2 says, suppose a sample of 400 participants, teachers and students, was randomly selected from middle schools and high schools in a large city. These participants responded to the following questions. Which type of movie do you prefer to watch? Action, drama, science fiction, or comedy? Movie preferences and status, teachers or students, were recorded for each participant. Okay, and then 2 variables were recorded. Are these variables categorical or numerical? Okay, so what are the 2 categories we are recording here? So for starters, who are being asked? It is teachers and students. And what are they being asked? Type of movie. Okay, so when I answer the question of type of movie, I would say action, drama, science fiction, or comedy. Those are all categories of movies. If I am asking if someone is a teacher or a student, that is a category. It's not a number. So the 2 variables that are recording are categorical. They're not numerical. Numerical would be how many texts do you send a week? And if you said 200, if your answer is a number, then that's a numerical data. Number 2, the results of the survey are summarized in the table below. So here's all the information. So there's our total. They told us that 400 were surveyed. And now we see how it's broken down. There were 300 students, 100 teachers. What proportion of participants who are teachers prefer action movies? So as soon as I see that word proportion, I know it's a fraction. Okay, in statistics, it's a fraction proportion. What proportion of participants who are teachers? So now we are focusing on just teachers. So I'm going to circle this. We are talking about that row. What proportion of those participants who are teachers prefer action movies? Well, action movies is right here, so that would be your numerator, and your denominator is the total number of teachers in that category. So it's 40 out of 100. So if I reduce that, it's 4 out of 10, or 0.40, which is approximately 40%. Okay. Let's erase that and answer B. So B says, what proportion of participants who are teachers prefer drama? So we're still talking about the teachers, so I suppose I could have just left that there. We're still talking about this row. What proportion of participants who are teachers prefer drama? Well, the drama's here. So that's going to be 20 out of that same total, 100, which equals 0.2 or 20%. Okay. And then I'm going to move this to what we're going to talk about next. What proportion of participants who are teachers prefer science fiction? Well, science fiction is right here, so teachers who prefer science fiction, the answer is 10 out of that same total of teachers, which is 100, and that equals 0.1 or 10%. And I shouldn't use equal signs, I suppose. It's still an approximation because it is a survey, and you would say approximately if this was going to be a representative of the population. You don't want to say it's exactly going to happen. You say it probably should be close to this, so we use an approximation. And D says, what proportion of participants who are teachers, so the row didn't change. We're still talking about just teachers. And this question is asking, of these teachers, how many prefer comedies? And the answer is 30 out of 100, which is approximately 0.3 or 30%. Okay. All right, now we have a table, and it says the answers to exercise 2 are called row relative frequencies. Notice that you divided each cell frequency in the teacher row by the total for that row. Below is the blank relative frequency table, and it says write your answers from exercise 2 in the indicated cells in the table above. So I want them here. We did teachers. So the answer from A goes here, B goes here, C and D. So I'm going to go back and look at those. So it goes 0.4, 0.2, 0.1, 0.3. So 0.4, 0.2, 0.1, and 0.3. Number 3 says, find the row relative frequencies for the students row. Write your answers in the table above. So now they want us to go back, looking at this, but now we are going to focus on students. So action was 120 out of 300. So I'm going to have to do these calculations. So I'm going to just do these one at a time. I'll use green for this one. So it's going to be 120 out of 300, which is 12 out of 30, which is 6 out of 15, and which is 2 out of 5, or 4 out of 10, so that's approximately 0.4. Then we're going to move on, and we're going to move this over to drama, and drama is 60 out of 300. So then I'm going to write 60 out of 300, which is 6 over 30, which is 1 over 5, which is 2 over 10, or 0.2. Hopefully you understand how I'm doing that, just saying it verbally. Okay, and then the next one is sci-fi. So if I move this over here, that's 30 out of 300. So 30 out of 300 is 3 out of 30, or 1 out of 10, which is 10%, or 0.10. Okay, wrong way. And then finally, the last one is comedy. Comedy was 90 out of 300. So that's going to be 90 over 300, which is 9 over 30, which is 3 over 10, which is approximately 0.3. Okay, now keep in mind what we're talking about here. We're talking about percentages of a population. So when you're talking about the whole population, that's 100%. So these should all add up to 1, because 1 is 1.00, and to make it a percent, you move it 2 decimal places to the right. So 0.1 equals 100%. So 0.4 plus 0.2 is 0.6, plus 0.1 is 0.7, plus 0.3 is 0.10, or 1.0, which is 100%. 4, 5, 6, 7, 8, 9, 10, 1.0 again is 100%. So you should always check to make sure your values add up to 1. Okay, so it says find the row relative frequencies for the students' rows and write your answers in the table above. We have just done that. So what proportion of participants who are students prefer action movies, and then drama, science fiction, comedy. So they were just telling us what to answer for this. Number 4, is a participant status, i.e. teacher or student, related to what type of movie he would prefer to watch? Why or why not? So when I look at this, 40% of the students liked action, same with the teachers. Drama, 20%, 20%. Sci-fi, 10%, 10%. Comedy, 30%, 30%. So, does it matter if you were a student or a teacher, the outcome of this survey? And the answer is no. Age did not matter. Okay, they match. So it doesn't matter if you're a student or a teacher, the outcomes were the same. Okay, number 5. What does it mean when we say that there is no association between two variables? Okay, number 5 says, what does it mean when we say that there is no association between variables? Okay, no association between two variables. Discuss with your group. Okay. No association means that knowing the value of one variable does not tell anything about the value of the other variable. Okay, that's what it means to have no association. Number 6, notice that the row relative frequencies for each movie type are the same for both the teacher and the student rows, which I've already mentioned. When this happens, we say the two variables movie preference and status, student or teacher, are not associated. Another way of thinking about this is to say that knowing if a participant is a teacher or student provides no information about their movie preference. What does it mean if row relative frequencies are not the same for all rows of the two-way table? Okay, it means that there is an association or a tendency between the two variables. So if the row relative frequencies are not the same, then there is an association. Number 7, you can also evaluate whether two variables are associated by looking at column relative frequencies instead of row relative frequencies. A column relative frequency is a cell frequency divided by the corresponding column total. For example, the column relative frequency for the student action cell is 120 over 160, which is 0.75 or 75%. Calculate the other column relative frequencies and write them in the table below. Okay, so I didn't have to go back 2 pages. I am just simply copying the diagram to here. So what they just explained here is student action cell. Student who like action movies is the numerator out of the total. So we're working columns this time. So 120 divided by 160 is 0.75. Okay, and then if I do the teacher one, well, keep in mind these have to add up to 100%. So it is 40 over 160. So I'm going to write that 40 over 160. But rather than reducing and trying to figure it out, well, 0.25 added to 0.75 is 1. Okay, so now I'm going to move this over to here, and so this is now the total. Let me change colors now. So this is now the total, 80. So I'm going to put an 80 down here. And I'm going to put an 80 down here because that's our total for this column. So this student drama would be 60 out of 80, and teacher would be 20 out of 80. Well, 6 over 8 is the same as 3 over 4, so that is equivalent approximately to 0.75 as well. And since these add up to 1 again, we're going to get 0.25, which is 2/8 or 1/4. Okay, now we're going to keep going in this order and move over to sci-fi. And now we are going to take the numerator divided by this total. So if I do science fiction, then I know my total's 40. So I'm going to start by just writing my proportion with my denominator of 40, and then put the numerator values from the table. Student sci-fi is my numerator of 30, and teacher sci-fi is a numerator of 10. So 30 over 40 is 3 over 4, which is also 0.75, and 1 over 4 is also 0.25. Okay. And then when we finally move to the next one, our total is now 120, and our numerator is going to be the cell that student comedy is going to be the numerator over my total. So I'm doing column totals now. Over 120, and the other one would be 30 out of 120. Well, 9 divided by 12, or 9 over 12, I mean, reduces. 3 will go into 9 3 times, and 3 will go into 12 4 times, and again, we're getting 3/4 or 0.75. And since these add up to 1, then I already know that this has to be 0.25. Okay, so there is our table. Now B says, what do you notice about the column relative frequencies for the 4 columns? Okay, and I would say they are equal. And of course you should say the relative frequencies for the 4 columns are equal. C, what would you conclude about the association based on the column relative frequencies? Okay, so to answer that, we say because the column relative frequencies are the same for all 4 columns, we would conclude that there is no association between movie preferences and status. Okay, example 3. In the survey described in example 2, gender for each of the 400 participants was also recorded. Some results of the survey are given below. 160 preferred action movies, 80 preferred drama, 40 preferred science fiction, 240 were female, 78 female participants preferred drama, 32 male participants preferred sci-fi, and 60 female participants preferred action movies. Okay, now it says to use the results from example 3 to answer the following questions. Be sure to discuss these questions with your group members. Complete the two-way frequency table that summarizes the data on movie preferences and gender. Okay, so I just plopped that data right in here so I don't have to keep going back page by page. Okay, so now we fill out this information that we are given. So let me get my pen going again. 160 participants preferred action movies. That's total. So action total is 160. Okay, so that's this one. I will do these in color. And 80 participants preferred drama. So that's a total. If it says participants, it doesn't say males or females, it's total. So that's this one. Okay, 40 participants preferred sci-fi. That goes there. 240 participants were female. 240 total participants, that's a total. 240s over here. 78 female participants preferred drama. So now we're filling in the drama. 78 females preferred drama. So females, drama, 78. Okay, running low on colors here. What can I choose? How about green? A different kind of green. Or how about brown? So when I check this one, 32 male participants preferred sci-fi. Male, sci-fi, 32. 60 female participants preferred action movies. So 60 female participants preferred action movies. That's not a very good color. Let me just change colors there. Purple. So let's do that, and let's go back to the most recent color I just had. It was purple, and that was 60 female participants preferred action movies. So that goes there. Okay, now I'm just going to fill all of these in using one particular color that we haven't used yet. How about like this peachy? All right. So, as you can see, I have one unknown. So in math, when we have only one unknown, we can find it. 160 minus 60 is 100. 80 minus 78 is 2. 40 minus 32 is 8. I don't know any of the comedy column. I'm missing 2 values in the male. I'm missing 2 values in the total. I'm missing 2 values in this total. But if I look at this row, I have 1 space. So 60 plus 78 plus 8 plus this unknown equals 240. So if I do this as a linear equation, or as a algebraic equation, 60 plus 78 plus 8 plus some value for comedy equals 240. Combine your like terms. 8 plus 8 is 16. Carry the 1. 8 plus 6 is 14. That is 146 plus x equals 240. Okay? And when I continue with this, I would subtract 146 from both sides and make that a 3, 10, 4, 2 to 1, 13, 9. So that is 94. Okay. So I'm missing 2 values here, missing 2 here, missing 2 here. Do we know a total? Total. Okay, going back, it says here, in the survey described in example 2, gender for each of the 400 participants. So there's the piece we were missing. 400 total participants. So I'll just put that in this color. 400 was also given. Okay, because there was no way to finish that if we had 4 values like the way they were set up to solve, we were not able to do so. So now in order to get this value here, it's 400 minus 240, which is 160. Now I have only one unknown here and one unknown here. So 100 plus 2 is 102, plus 32 is 134. So I need another 26 to get to 160. 6 plus 4 is 10, carry the 1. 9 plus 2 is 11, plus 1 is 12, 120. So 160 plus 180 plus 40 plus 120 is 400. So there is our table complete. Okay, so I'll get rid of my work there and now answer questions about this. What proportion of participants are female? You see the word proportion? Let me change colors, that's not my favorite. Let me use blue. Proportion tells me that there's a fraction. What proportion of the participants? That keyword there tells us of the total participants, 400, are female. Total females, 240. 240 over 400, I wrote 200. 240 over 400 is 24 over 40, which reduces to 12 over 20, which reduces to 6 over 10, and there we have it. It is 0.60, 60%. If there was no association between gender and movie preferences, should you expect more females than males or fewer females than males to prefer action movies? And explain. Okay, this explanation is quite lengthy, so here's the answer. If there was no association between gender and movie preference, then I would expect more females than males to prefer action movies because there are more females in the sample. However, if there was an association between gender and movie preferences, then I expect either fewer females than males who prefer action movies or considerably more females than males who prefer action movies. Okay. 11. Make a table of row relative frequencies for each movie type. For the male row and female row, refer to exercises 2 through 4 to review how to complete the table below. Okay, so I copied this over to make this easier. And so here we go. Female action movies. Female action movies. Movie preference. 60 out of 240. So what we're doing here is we take the female action movie value, which is 60, divided by, now it said that we are doing row. Let me move this for a second just so you see. Make a table of row relative frequencies. So when it tells you row relative frequencies, we're working this way. So in this row, what's our total? 240. So since it's a row relative frequency, it's going to be 60 over 240, which is 6 over 24, which reduces to 1 over 4, which is 0.25. Drama, 78 over 240. And that is approximately, to save time, I'm just going to plug it in my calculator, and that is 0.325. And then the next one is going to be 8 out of 240, which is a third. Okay, so be careful with your decimal place. 1/3 is 0.033. And comedy is 94 over 240. And if I plug that into the calculator, I get 0.392. Okay. Males. First, let's do the fractions. 100 over 160. Over 160. Over 160. Over 160. 2. 32, 32, 26, 26. Do the calculation. 10/16 is 5/8. 5/8 is approximately 0.625, or it's exactly actually, but anyhow. And 2 out of 160 is 1 out of 80, and that is 0.0125. And 32 out of 160 comes out to be 0.2, and 26 out of 160 is approximately, or is 0.1625. Okay, suppose you randomly pick one of 400 participants. Use the table of row relative frequencies on the previous page to answer the following questions. If you had to predict what type of movie this person chose, what would you predict? So if I go back and look at this, I need to look at this table we just had. And if you were just to pick one person, who would be the most likely person to choose? What is the highest number? What number is closest to 1? If I look up here, I see that 100 is the biggest number of these 8 numbers. And that gives me 0.625 or 62.5%. So I would say it'd be a male who chose action. Yes? So let's take a look. So the answer should be the participant likely prefers action movies because the larger proportion of participants preferred action movies. So when we look there, 160 is more than 80, 40, and 120. And that's where that comes from. Okay, we could narrow down even more, and we could say it was possibly a male who preferred action movies. Number 13, if you know that the randomly selected participant is female. Okay, so we know the participant is female. Would you predict that her favorite type of movie is action? If not, what would you predict? So we want to just look at the females in this row. And action is 60, drama there were 78, science fiction there was 8, and comedy there was 94. So I would say no, I would not predict action. That's only 60. That came in 3rd place, 94. Comedy was the most popular. So I bring my answer in. Okay, let me just reduce this down. And there it is. No. Female participant is more likely to prefer comedy since it has the greatest row relative frequency in the female row. Number 14 says, if knowing the value of one of the variables provides information about the value of the other, then there is an association between the two variables. Is there an association between the variables gender and movie preference? Explain. So, if I go back and I look at gender and movie preference, do we have any that are the same? 60, 100, 78, 2, 8, 32, 94, 26. And they're different, so what's the answer is yes. The row relative frequencies are not the same. They're not even close in each row in the table. So there is an association. Remember, if they're equal, there's no association. Okay. 15 says, what can be said when two variables are associated? Read the following sentences to decide if each sentence is a correct statement based upon the survey data. If not, if it is not correct, explain why or why not. More females than males participated in the survey. So I go back and I look. There were 240 females, 160 males. That is correct. So I'm going to write that. That is correct. Males tend to prefer action and science fiction movies. So I go back and I look. Males, action 100, science fiction 32, drama 2, comedy 26. Those two categories were more than the other two, so that is correct. And being female causes one to prefer drama movies. I would say that would be incorrect. Okay, this is not cause and effect relationship. Okay, association does not imply cause and effect. That is incorrect. Okay, that is the end of lesson 14. Review the lesson summary and go do your problem set.